Today we are going to talk about the definitions of derivative. Definitions of derivative. We started this year talking about limits. We then moved into continuity. And those two things together set the foundation for the rest of first semester, which is all about derivatives. Okay? For the last few days, we've been talking about difference quotients and average and instantaneous rate of change. Instantaneous rate of change is actually what a derivative is. And today, as you can see on the board, it says we're going to learn the three versions of the definition of a derivative. And then we're going to learn how to find derivative values with each of those formulas. Okay? So what I'm going to do is, as we do the notes, we're going to set the stage for derivatives. I'm going to show you one of the formulas one at a time, one of the definitions. I'll even tell you which problems on the homework it goes with. And then we'll do a practice problem using those. So by the end of class, you should be able to use all three definitions and calculate their derivatives. All right? So the first thing we're going to talk about is what a derivative actually is. Now, the connection to prior knowledge is IROC. IROC stands for instantaneous rate of change. And IROC and derivative are synonymous. They mean the same thing. We use the word derivative more often because it's a lot shorter to say than instantaneous rate of change. It's too many syllables. Not really. But derivative is basically what it's called. And it is a formula for the slope of a tangent line to a curve. It is the formula for the slope of a tangent line to a curve. And we'll talk more about that as we do some sample problems. Okay? Now, because we're coming into a new word and a new concept, we're going to do what we did at the beginning of the year with limits. We're going to take a little bit of time and talk about notation. There are different notations for derivative. How do you write it down and how do you say it? We're going to focus on that for a few minutes. So after you write down notations for the derivative, I want you to write three columns. First column is going to be function. The second column is derivative. And the third column is read as ... So basically, if I give you a function looking like this, this is what its derivative looks like, and this is how you say it, because you're going to have to be able to read it. Now, calculus was developed by two different mathematicians in two different countries, one in England, one in Germany. And so as they each worked independently to develop calculus, they had to come up with their own notation for a derivative. So that's why there are four different ways to write a derivative down. And you just need to know that they all mean the same thing, it's just a different way of writing it. Okay? Just like you know that the words rate of change means slope, all of these symbols are going to mean derivative. And I'm going to put them in order from most common to least common. Okay? So the first one, since we work with f of x so much, that's the one we're going to start with. So if a function is written as f of x, its derivative is written as f with an apostrophe and then the parentheses and the x after it. F and then an apostrophe and then the parentheses and x. And this is read as f prime of x. That's how you say it. They call that apostrophe a prime, f prime of x. If instead they decide to use y instead of f of x, they write it with y with the apostrophe, and it is read as y prime. And it just means derivative. Okay? The other way that it's written with y is a takeoff on the way that you learned how to write slope in Algebra 1. And it is written as dy over dx. Now, what is that like? That is like the change in y over change in x that you learned in Algebra 1. And change was written with a triangle, which is the Greek letter delta, which is the Greek letter D. So for calculus, they changed the delta to a D, and they call it a dy. So when you read it, you don't say dy over dx like you do with a fraction. You just say dy dx. And it's understood to be written as a fraction. Don't say over, don't say fraction bar, just say dy dx. But you write it as a fraction. Okay? The final one is similar to this, but the way you write it with f of x. So put f of x, and we write d over dx, parentheses f of x, like so. D over dx, and then a big parentheses in f of x for the whole size of the d over dx. The f of x is not on the bottom of the fraction, it's next to the fraction. Okay? And when you read this, you just say d dx of f of x. D dx of f of x. And it means derivative also. So, as you see the problems over the rest of the semester, they're going to use any one of these notations for derivative. And you just need to know, I'm supposed to do the derivative thing here. And now I'm going to teach you the derivative thing. How do you do that? How do you find a derivative? So the first method we're going to talk about today is called the formal definition of derivative. Formal definition of derivative. Okay. This formal definition is a takeoff on the IROC formula that we came up with the other day. Okay, when we did the AROC and IROC notes, this is the IROC formula, except that instead of having x's and delta x's, which can get very confusing when you start working out the problem, this one has x's and h's in it. So the delta x is changing to an h. So the formula is the limit as h approaches 0 of the following fraction: f of x plus h minus f of x all over h. F of x plus h minus f of x over h, and this equals f prime of x. So I'm going to kind of box that in. That's definition, formal definition number 1. Okay. Now, what I want you to notice, and you probably did the other day if you worked on the rates of, on the AROC and IROC worksheet, or the rates of change worksheet, this is an ugly limit because it's got x's and it's got 2 variables. But when you're done, you don't end up with an answer. You actually end up with an equation that has x's in it. And this is the only one of the 3 definitions that does this. So we're going to end up with an equation, not a number. Okay? This is for problems number 9 through 12. So write that in the margin. So when you do the worksheet, this is going to apply to problems 9 through 12. And now let's do a sample problem. The directions say find f prime of x for f of x equals x squared minus 3x plus 1 using the formal definition. I'm going to abbreviate like crazy. Find f prime of x for f of x equals x squared minus 3x plus 1 using the formal definition. Okay, so we're actually going to find the derivative equation for this. First thing I want you to do with any one of these problems is to copy down the formula. So we have limit as h approaches 0 of f of x plus h minus f of x all over h equals f prime of x. Okay, now we know what formula we're supposed to use. What we need to see now is everything we need to proceed. Okay? The problem is asking me to find f prime of x. F prime of x is the right-hand side of this equation. So this is what I know is my unknown quantity. So when I do the work, I'm going to ignore this. I'm going to pretend like it's not even there until the very end. Okay? So I need to see, do I have everything over here that I need? Do I have f of x? Did they give me a function? Well, yes, it's right here. I don't know quite yet, though, what f of x plus h is. So I'm going to write that in the margin. Some of you may already be able to do this in your head, but I want to talk about it for those who don't just quite see it yet. The more you practice with this, the easier it gets. Okay? So I need to know what is f of x plus h, because I got to plug it into this equation. Now, it's based on this function right here. If I asked you for what f of 0 is, what would you do? Plug in 0. If I asked you for what f of b was, if I said what is f of b, all of the x's would do what? Change to b's. So whenever it says find f of something, you change all the x's to that something. Does that make sense? Okay. So I want to write this down, and for both of these x's, I'm going to change it to x plus h. So x plus h squared minus 3x plus h plus 1. So that is what f of x plus h is. And put that in parentheses. I need to plug that into the equation in just a minute. So now we're going to start doing the math. I'm going to move over to the left so I got plenty of room. Limit as h approaches 0. I need to now plug in f of x plus h. So all this stuff on the right, I got to copy it down. X plus h squared minus 3x plus h plus 1 is f of x plus h. I'm going to draw my fraction bar. So f of x plus h, which is all this mess, minus f of x. Now f of x is given to me in the problem. Since it is minus all of this, I have to do what with this? I have to put it in a parentheses, otherwise it's not going to work. So minus parentheses x squared minus 3x plus 1. Now some of you may be very adept at just automatically changing all the signs. You can do that if you're good at it. If you're a little bit shaky, I'd go ahead and write it this way. I prefer to write it this way. Now the denominator is just an h, so we write that down. And we're going to not write down the right side because that's what we're solving for. Okay. Ta-da, a limit problem. You know how to do limits now. What is the method we always try first with a limit problem? Direct substitution. So h is supposed to be a 0. Let's see what happens. So x squared minus 3x plus 1 minus, the same thing. So the top is 0 and the bottom is 0. 0 over 0 means got to keep going. Now, some of you may think, well, that looks squared, so it looks like I may have to factor. Yeah, that's a good thing to try, but there's a lot of mess up here. This may be able to clean up just on its own, just doing simple algebra. So that's what I'm going to do first, then tackle what's left over. So the next step is going to be to FOIL all this out and collect like terms. That's the first thing I want to do. So I'm going to go down a line. Limit as h approaches 0. Make sure you write that limit down. X plus h squared means it does not mean x squared plus h squared. Do not do that. You cannot distribute a squared into a plus sign. What we are going to do, I wrote a second one above it, and I'm going to FOIL it, just kind of stacking. So it's going to be x squared. xh is outside, xh is inside, so that's going to be 2xh plus h squared. That's the first two FOIL together. Now we distribute the negative 3, so that's negative 3x, negative 3h, plus 1. That takes care of everything up to the minus sign. Just scoop that up. Now I need to distribute the negative into the second parentheses, minus x squared, plus 3x minus 1, all over h. Okay, do you guys see any like terms that are going to collect together or possibly even cancel? What cancels? X squared. X squared, boom, x squared. What else? I see the 3 x's, and I heard somebody else say the 1's. Yeah, the 1's cancel also. Anything else cancel or add together? Okay. Actually, everything else is still different, so I can't add them together. Let me give you a little hint. If you come across a problem like this, if you do it correctly, everything that is left after crossing stuff out will always have an H attached to it. Does everything up here have an H attached to it? Yes. If anything is left over that doesn't have an H attached to it, you made a mathematical error. Okay? So keep that in mind. So now let's write down what's left. Limit, H approaches 0. Still got to write limit down. So I have 2xh plus h squared minus 3h over h. That is much better than what we started with. Okay, so maybe we can plug in 0 now. If I plug in 0 now, am I still going to get 0 over 0? Yep. So I'm not done yet. Who knows what we can do next? Okay, I can cancel the bottom h, but if I have to do it very carefully. I can't just say h goes into h squared. I can't just say h goes off of here. You have to factor the h out of the top in order to cancel it with the bottom. If you see plus signs, you've got to factor first. So, limit, h approaches 0. Limit stays until h goes in, and h isn't going in yet. So we pull out the h. We have 2x plus h minus 3 over h. Now that the h is completely isolated from the rest of the problem, I can cross those two out, and that is my 0 over 0 going away. Now, with what is left, can I safely plug in 0 for h? And the answer is yes, because the bottom is a 1. So my answer here is going to say 2x minus 3. Box that in. Okay. All of these problems are actually going to have two boxed answers. They're going to have this, and then I want you to take and write an equation of what you just found. Find f prime of x. That's what this is. So below it, I want you to write f prime of x equals 2x minus 3. Okay. Now, that's a really strange answer for a derivative, because I told you that a derivative is a slope. Well, how in the heck can a slope have an x in it? As far as you know, slopes are numbers, right? Slope is 5, slope is negative 2. This right here is called a derivative equation, also known as a slope generator. So let me explain what that means. Go back to the original equation. What kind of graph is this? It's a parabola. So picture a parabola in your mind. Parabola, just going like this, okay? What this says is, I don't care what x value you pick. The slope at that point is going to be that x value times 2 minus 3. So let's try it. This is a parabola. What's the slope at 0? What is 2 times 0? 0 minus 3. Negative 3. So I automatically know that on this parabola, when x equals 0, the slope is negative 3, excuse me. If I plug in 2, if I say, what's the slope at 2? I go down here to the slope generator, plug in 2 for x. 2 times 2 is 4, minus 3, the slope is 1. So for any curve, if you took a curve, a parabola, and you took the slope at every point along the curve and put those into a t-chart where the x was the x and the y was the slope, listen to me, listen to what I'm saying. If the x was the x's and the y's were the slope, it would make a pattern. And that pattern is this equation. Now, I know you're still trying to wrap your brains around that. We're going to do more with that as days go on. But this is a slope generator, okay? That's what you're doing. Do I have any questions up to this point? Okay, let's do the second definition of derivative. Just made a mess. Okay, the next two are a little bit easier because they come out to be numbers instead of equations. So number 2 is the alternate definition of a derivative. Alternate definition of derivative. And out in the margin, please write numbers 5 through 8. That's which problems this goes with. Okay, underneath what you just wrote for the title, please write this down. This finds the derivative at a given point. So for this definition, they're going to say, find the derivative at 2. Find the derivative at negative 5. Something along those lines. They're always going to give you a point if you're going to use this definition. And this problem is, I think, a lot easier. Or the formula looks a lot better. So here's the way the formula looks. The limit as x approaches a of f of x minus f of a over x minus a equals f prime of a. Limit as x approaches a of f of x minus f of a over x minus a equals f prime of a.
Are the brackets part of the formula or just...
No, I just do them parentheses. Good question. Brackets are not part of, okay. Now, how is this different over here? What did the other formula have in the parentheses? No, it had an x. So when it has an x, you're going to have an x in your answer. Since this a is a number, you're going to get a number answer, okay? So, here's the problem. Next example. Find the slope of the tangent line to f of x equals 1 over x. That's your curve. Find the slope of the tangent line to f of x equals 1 over x at x equals 3 using the alternate definition. Alt def of derivative. Yes, please abbreviate. Okay, so let's kind of get in a picture in our mind what we're doing here. You don't have to graph this, you can see it. Here's 1 over x. We're trying to find the slope of the tangent line at 3, like right about here. What's the slope going to be? Is it going to be positive or negative? What do you think? It's going to be negative, but we're going to actually calculate what it is using the definition, okay? I'm going to pull that aside. So the first thing I want to do is tell you this. They will always give you a number. That number is what a is. So make a note to yourself right here that this number 3 is the a. And when you write the formula down, you need to go ahead and plug in 3 for all the a's. Right off the bat. Now I know it says x equals 3. Don't let that confuse you. X is approaching 3 as you're finding the slope. So that's into, excuse me, the 3 turns into your a value. So here's what we write. Limit as x approaches 3 of f of x minus f of 3 over x minus 3 equals f prime of 3. All those a's turn into 3's. First thing. Okay? Now, the question tells me to find the slope of the tangent line to the curve at 3. That's what the right-hand side of this thing means. F prime of 3 means the slope at 3. So this is the part we're going to ignore. This is the part we're going to work. Okay, so do we have everything? Do I have f of x? Yes, it's right here. I need to know what f of 3 is, because I got to plug in a simple one, right? What is f of 3? 1 over 3. Okay, so now let's redo the problem and plug in what we've been given. Limit as x approaches 3, f of x, which is 1 over x, minus f of 3, which is 1/3, over x minus 3. There's my problem. Don't write the right side down. Okay. This one's better, a lot better, because there's only one letter in there, x, unlike the last one, which was x's and h's. If I plug in 3 for x right now, am I going to get 0 over 0? Yes. So I got to keep going. What is the keep going method for this problem?
Chopsticks in a bowl.
Chopsticks in a bowl. Here we go. 1, 2, 3. Time to chop. Time to chop. Equals limit as x approaches 3. Fraction bar. Okay, let's make sure we all remember how to do chopsticks. What do you write first? 3 or x? 3. Very good. So 3 minus x over 3x. Are we good with that? That was a very simple chop. And then the bottom is x minus 3. That's a little bit better. Okay, what's the next step? Multiply the denominator up. So put the denominator over 1 and flip it up. So 1 over x minus 3. Lightly mark that denominator out so you realize it's gone or it's moved. So now go to the next line. Limit x approaches 3. Now I have one fraction left. 3 minus x times 1 is just 3 minus x. Do not FOIL out the bottom. Okay, that's better. No fractions inside of fractions. If I plug in 3, am I still going to get 0 over 0? 0 on top, 0 on the bottom. Yep, I still am. Okay, so something's got to go. Something's got to cancel. Can I 3 minus x with x minus 3? Are they the same thing? No. Very good. Is there a way I can make them the same thing? How? Factor out a negative 1. So if something is backwards, you factor out a negative 1. So we're going to do a negative 1 out of the top. That's going to turn it into a positive x and a negative 3. So I just turn the whole thing around. 3x, x minus 3. And with the help of some little bit of algebra magic, I can now cross out those x minus 3's. Now if I plug in 3 for x, am I going to get an answer? Yes. And that answer is, because I'm plugging in 3, I don't write limit anymore, negative 1 over 9. Box that answer. Okay. Now, box number 2 is taking what was the right-hand side of the equation that I didn't mess with. F prime of 3 equals negative 1 over 9. Write an equation with that. Okay. You need to know what this means. So I'm going to give you about 1 minute to talk to your table and see if anybody there knows what this means in terms of that equation. In terms of that beginning of the problem. What does that mean? All right. Gotta go right now. Okay, anybody willing to say for everybody else what this means? What does it mean? Any brave souls out there? Okay. What does f prime mean just by itself? F prime means slope. So the slope at 3 is negative 1/9. Didn't we say the slope was going to be negative? Yeah. That's the slope of that tangent line. Okay. Let's now look at the third definition of derivative. Number 3 is called formal definition at a point. Formal definition at a point. And out in the margin you can write down, this is for problems 1 through 4, the very first 4 on the page. Now, the first one was also called formal definition. That's because these two are related. What this one is the exact same formula as the formal definition, except for the fact that all the x's are going to turn into a's. So here's the way it goes. It is the limit as h approaches 0 of f of a plus h minus f of a all over h. F of a plus h minus f of a all over h, and it equals f prime of a. Not f prime of x, f prime of a. Once again, just like number 2, You're going to be given a point in order to do this problem. That's why it's called at a point. So our final example, or the one that goes with this, says the following. Find f prime of 3 for f of x equals the square root of x plus 1. Find f prime of 3 for f of x equals the square root of x plus 1. And then please add using formal def at a point. I'm going to abbreviate like crazy to make it fit on that line. Formal definition at a point. All right, so what we're going to do is we're going to take the formula we wrote down here. What is a this time? What do they tell me that a is? What number? 3, the only number in the problem. So that's a. So when we write the formula, we got to put a's, change the a's into 3's. So we're going to write limit h approaches 0, f of 3 plus h minus f of 3 all over h equals f prime of 3. Okay, the question said find f prime of 3. Well, that means that I don't know this side, so I should be able to come up with everything over here. Now the one difference between this problem and the two that we've done before, there is not a single f of x in this problem anywhere, so I'm not even going to plug this formula into here, but I need it to find both of these on top. So I'm going to come out to the side and over here do f of 3 plus h and f of 3. Those are the two things that I need. I'm going to actually calculate f of 3 first because it's easier. When you substitute 3 in for x, what is your answer going to be? It's just 2. Now remember that when you substitute in 3 plus h, it's going in place of the x. X comes out, 3 plus h goes in. So the square root of 3 plus h plus 1. That's what that one is. Didn't leave myself a whole lot of room. All right, so now we're ready to work the problem because we know what two things to plug in on top. So the limit as h approaches 0. Draw my fraction bar. The first thing I want to put in is f of 3 plus h, which is this top thing right here. But when I put it in, I want to clean it up a little bit first. So what's it going to clean up to be? What do you think? 4 plus h in the square root sign. Square root of 4 plus h. Exactly. Minus f of 3 is 2. So put a 2 there. And h on the bottom. That's it. If I substitute in 0 right now, am I going to get 0 over 0? That would be the square root of 4, which is 2. Minus 2 is 0 over 0. So yes. So in this looking problem, what do I do to keep going? The conjugate, exactly. So we're going to multiply top and bottom by the conjugate, square root of 4 plus h plus 2. So now I need to FOIL out the numerator. What is the square root of 4 plus h times the square root of 4 plus h? 4 plus h. Outside and inside always cancel with conjugates. So my last is going to be negative 4. Agreed? The denominator I am not going to multiply out. And you'll see why in a minute, if you don't already know why. Okay. Can I do some minor cleanup here? What do you think? What can I get rid of? The 4's. Now, once the 4's are gone, can the h's cancel? Yes, they can, because the only thing up here is an h. This h is isolated. They can both be canceled. So now I have the limit as h approaches 0. What's on top? 1 over the square root of 4 plus h plus 2. Now can I plug in 0 and not get 0 over 0? The answer is yes, because the numerator cannot be a 0. There's no way. Now remember, as soon as h goes in, limit goes away. So I'm just going to write 1 over the square root of 4 plus 2, which is 1/4. So my final mathematical equation is going to say f prime of 3, which is what I'm searching for, equals 1/4. The slope of this curve, x plus 1 at 3, was 1/4. That's what it says. Questions on that? Okay. Now, finally, are the interpretation problems. So I need to turn the page. Is everybody done writing? Okay. Please write this down. Interpret the following. This is for problems number 13 to 15. Interpret the following. So basically, I'm going to give you a problem that has already been written into the form of one of the formal definitions. I want you to identify it and tell me what it means. So the first one, A, is going to look like this. The limit as h approaches 0, cosine of x plus h minus cosine of x over h. Give me a second to write that down. Now that just looks like a limit problem to me. Yeah, limit problem. If I plug in h right now to be 0, am I going to get 0 over 0? Yes. Okay. Have I ever taught you how to do a limit like this? Not with a cosine of things added together. I can tell you right now, I've never taught that to you. Thing is, though, I'm not sure I could do this problem, to be honest with you. There is some calculus that's beyond this, definitely beyond the scope of this class. I think I could play with that for a little bit, might get it to work, but I don't expect you to. I don't want you to find the answer. I want you to tell me what that problem is asking. What is it asking about? So the first thing I want to know is, what does the other side of the equal sign say? So I need you to go look at the 3 different formulas that we used and tell me which one this matches. Which formula did this problem use? Formal, alternate, or formal at a point? This is formal only. So out to the side, I'm going to write formal definition, or formal def. That's what this one is. Okay. So the right-hand side of the formal definition equation says f prime of x. Doesn't say f prime of 2 or f prime of 5. Okay. And now what I want to do is write in a quick phrase what this means. What did I tell you f prime is the same thing as? What does that mean in words? It's a derivative, right? So this is the derivative of f of x equals what? What equation is this problem taking the derivative of? What equation is this problem taking the derivative of? Some of you may have a guess and think it may have something to do with cosine. Maybe. Let's go back and look at formal definition real quick. So here is what the formal definition looks like right here. Notice that f of x is actually part of the formula. So whatever's past the minus sign on top, that's f of x. So go look. What is it? Cosine of x. Period. Oh, it's not a period. It's not a true sentence. That's the answer. This problem would find for you, if you could work it, the derivative of cosine. That's what it's saying. Okay? Now, letter B, real quickly. Limit h approaches 0, sine of pi plus h minus sine of pi over h. This looks almost identical to that one. The only thing is, it doesn't have x's, it has pi's. So this one happens to be formal at a point. Formal at a point. Okay. Now, it is f prime of a. Now, what is a in this case? Pi. Very good. A is pi. You may want to make, put an arrow, show that that's a. So this problem is finding the derivative of f of x equals sine of x, kind of jumping ahead because the bell's about to ring, at x equals what value? At pi. Now, how did I know this was sine? Because just like this one, this is f of a, so that has to be sine of x. Does that make sense? Okay. Thank you very much for your attention. You can now complete that worksheet. I've done a sample problem of every type that there is.